Geez, sure glad you folks were able to make it just in time, boy. Yes, sir. The train was leaving the station and you guys were still running to catch it. And now you're able to hitch your caboose and back out the gator train. You don't know where we're going this morning, but it just followed me and we'll be going somewhere. There's a project. We started that a few days ago, and I'm gonna try and just show people what happens when you load a circuit up, okay, and the dangers of it, and a lot to do with at this time of the year with resistive heat. You don't have enough heat in your house, and you buy these little flimsy heaters there, and nothing wrong with the heaters. Most of them have safeguards like thermal cutouts inside of them built in, and if they fall over, they kick out. I think the safest one is really the oil-based ones, built more or less like a hot water tank with an immersed element in them. That's the worst ones are the radiant ones and ones with the tubes there. Well, I've seen them tubes there. All of a sudden, it just blows, eh? Like like the old stove elements used to do that. Those tubes are more or less the same thing as those circular elements that used to be in the stove. What happens with time, I guess the resistance just deteriorates at one particular spot, and then you'll get a blowout, eh? And when it blows, it just spits molten, not lava, molten copper that's within the powder inside there is semiconductive, and without going through the whole 9 yards of how these work, but okay, I'm just gonna, our little contraption here, it's comprised of two plugs. See, the power comes in the bottom one. That's how I have it wired. Okay, comes in the bottom one, and then it's wired in the way that the power goes from the plug back there. But that we don't talk about that in the wall. That's just the way I did it. But really, this would have been a circuit going direct to the panel, which is the home run. And power comes into the plug, leaves the plug, goes into another plug, and this is where we're going to put our load. A load is measured in amperes, and to a maximum of 15 amp. That's what it says on the breaker, but there's a percentage that you're allowed to draw, and there's a safety factor built into the breakers, eh? But the maximum you'll be able to draw is, I just had something that came to mind. There was a discussion on the net, I don't forget who had it, about putting breakers in parallel. If you could, one time, I won't say it. Well, I did that before, okay? I was welding in it was a commercial complex, and there was a panel, and I couldn't get, I think I had 20 amp breakers. That's what was in, and without taking these breakers out and trying to find a double pole breaker to fit in the panel, and they were screw-in breakers, screw type breakers. So what I did was just run a pigtail from one breaker on the same polarity, like two pigtails, and then I ran like that, and I was able to weld with a welder, but with just a 20 amp breaker, it was blowing all the time, eh? But don't do this. I can do it because I'm an electrician, but you guys can't do that. Okay, get back to this here. Okay, I'm just gonna show you why resistive heat. Okay, these little heaters here, but I got, see this here, it draws about 750 watts. This here draws 1500, I think. Is there a nameplate on here? It doesn't say in watts, but it draws 18 amps. So this is a good load. 18 amps. The breaker is good for 15, so that means eventually this. See, the breaker it's got a thermocouple in the breaker. It'll heat up. It'll endure a certain, like maybe 2-3 minutes. It'll take maybe up to 20%, 20 amps. Like it'll go up to 115%. I don't know. You figure it out. Like 20 amps, and that's not even. I'm just thinking of that, but around that 20 amps, and then eventually it'll come down to 15 amps. So this will blow the breaker. But it's a good load for our test this morning. Okay, right off the get-go, another thing too. Gonna be using our tester here. We'll be reading the amperage with this. Okay, remember we put the wire right in this little slot here. It tells us the amperage. Okay, we're gonna be using this, and we're gonna be using this. This test. I don't know who makes that. It's an infrared thermometer with a dot on it. It's pretty accurate too. I don't have no what do they call that? Infrared cameras? That would be ideal, but I don't have none. But we're gonna read the temperature, okay? Right now, hang on. Can you see that? Right now we got 2 degrees on that screw and 2 degrees on that screw, okay? I got the power on. The power's on, but I have no off. Well, another thing too, didn't show you that. Hang on, I gotta raise this, guys. You can't see, eh? See up here, folks? I got a light bulb. I don't know if I can see that. No, you can't even see it. Hang on. I'll have to bring this down, but maybe I have to back you up there. You're too close. You got on the train, but you got in the first boxcar. You should have been in the second one, eh? Hang on, I'm gonna lower that there. Get a complete view of things. Yeah, but I'm gonna have to. Hey, light bulb. You can see that. And okay, I'm gonna read this. The temperature on this one. We used to have one. Now we got 1.3 on that one. Okay, on the screws. Okay, that's the screws are where the wires are. This one here on the screws, but see one degree. Hang on, I don't know if I can change that. I can. So it'll mean a little bit more of something to our American friends. I don't know how you change that. Ooh. Okay. We're gonna have to do it in Celsius. I don't know. I didn't think that. Is it necessary for me to tell you as I didn't read the instructions? Oh, you lady friends in here, you know us, man, how we do it, eh? We don't read the well, we read them only. See, it's just because we don't want to waste time, eh? It's all it is. See, just imagine how much time people waste in a day reading the instructions, eh? Okay, I'll bring us in there. We'll start this off. This one here. Yeah, okay, we got an eyeball on it. So I'm gonna start. Okay, I'm gonna start my load. Okay. There'll be a little bit of okay, I had okay, 2 degrees Celsius, okay? Oh my God. No. Look here, folks. See that, folks? See that? Right there. You know how much that is right now? 65 degrees Celsius. That's hot. Hang on, I'll shut this off. Now, this, all I did, okay? Oh, hang on. Ooh, yeah, I'm getting carried away with myself there. Getting carried away with myself, yeah. All I did was I just this hang on, I should be pointing here. Okay, this here. Okay, it was 2 degrees right now. See, hang on, I don't know if you can see this. We're still at 25 degrees Celsius. That's hot. Summertime weather. Here, the top I read there was 75. Okay, and you could see it was smoking. You can tell. Hang on, I want to show you. And see, this draws more than 15 amps two-way, so I didn't really have to bring in this other heater. I'm just gonna show you. See the wire right here? See the wire, how it's melted? And all I did, hang on, I'll try to hose you stable. All I did was I loosened this, hang on, there. I just loosened this by that much. Not much, eh? Just that much. Okay? But what happens, okay, hang on, I'll put you as, see, maybe I didn't need that. I had a light up there and the whole 9 yards. The whole 9 yards, yeah, you know, Gator. I didn't need all this. I put a switch up there and I put a light. This is just to demonstrate that if, you know, like you were talking about they as in the inspectors and the electrical departments. Remember the days when they put aluminum wire in the house? Well, that was bad. I remember because I was an apprentice then, and I remember wiring houses, okay, with aluminum. And yeah, we knew then. Well, this lasted for about, I don't know, I can't say exactly there, but around 10 years of putting aluminum wire in houses, eh? Well, after that, they had fires and proved to be not a good thing. And what they made people do is put these pigtails on the aluminum wire. But as soon as you in the boxes, okay, hang on, I'll turn this around. This is in the boxes, okay, and the wires coming in the boxes. Well, as soon as you flex the wires, like you bring it out, like the wire was straight out, okay, the electrician did the ground and all that, then he pushed it in the box, okay, they did the drywall. Then then the electrician comes back. Hang on. Electricians come back. Then he puts his plugs and switches on, and his fixtures. So that pulls the wire out, pushes it back in. So every time that wire moves, okay, you're doing that with the wire. So that becomes a weak point in the wire, okay? Now, what I'm about to tell you is probably the most important thing. There's joints, well, here's a joint right here, okay? Whoa. Here, you can't even see, right here, okay? At the plug there. That's a joint. See, I loosened the screw just a little bit. You seen what it did? All those joints, when the houses are built, especially here in the northern climates, like if they're built in the winter time, electrician puts all his switches, his plugs on, puts his fixtures on, does the joints in the ceiling lights, which are octagonal boxes, and some of them have 3 wires coming in, so he does all the joints in them. And well, if they're done in cold weather, he tightened them, and then he put more connectors. Hang on, I got a smaller one here. More connectors, okay. More connectors. He puts those on, and it's tight when he puts it on. Cold weather. Then it warms up, so it expands. Then it cools off, contracts. Just being in the house, in the weather like that you have in the house, expansion, contraction, different humidity. It works. The wires, even copper. This is why I'm talking about this, because aluminum, well, they think these solve. This is going to lead to something. So hang on now. They solve the biggest part of the problem, but even though the copper aluminum problem is solved, there's even problems with the copper, especially when you're putting a draw like this on your circuit. Like if you got a heater that draws 15 amps, and you seen this here, this is a this plug is capable of 15 amps, but it's not the end of the world, because it's a weak, if there's like if the screws are not as tight as they can be, like tight to almost squeeze the juice out of the wire. They gotta be tight. A good connection. Connection with no okay, see here it already sparked, Well, if I was to tighten that and not clean it, there's carbon buildup in between the screw and the wire. Well, that'll never be a good connection. You gotta sand that down, make your connection, bring it in tight. Then you're sure that, but it's still, every joint is resistant. It's a resistive point in your wire, okay? Plug in. Hang on. Plug in. See that? Just to plug in. You plug. Okay. I know I'm jumping around, but try to understand, people. Just your plug on your heater. That's a resistance. Okay? It doesn't have the same. And most of these heaters, like this here, this heater, this blower, I think this is rigid. This here. It's good quality. It's the cap tire on it. The plug. Look, this is the heater you buy. And then this is the heater you buy. Okay, look at the size of the cord. And this is a heater. This is a industrial duty blower. Yeah, not a blower. It's not an air blower, I'll tell you that. It's for heat shrinks and things like that. But this is industrial duty. And this is the end plug on it. And these even that sometimes heat up, okay? Oh, just by the way, this has been doctored a little bit. We're electricians, so we're allowed to do it. I'll bring this in close and you can see. See this prong right here? It's horizontal, and we took a pair of pliers and we twisted it vertical. Because, see, this is not really made to plug in a normal plug. It's made to plug into a 20 amp 110 volt plug. Okay, one goes horizontal and the other one goes vertical. But like I said, we're electricians, we're allowed to do this. I'm sorry. That's it. We understand the danger. See, this is a tool. You plug it in, you use it. You're there when you're using it. It's not like it's. Hang on, I'm all tangled up there. Getting excited here. Get some getting hot around the collar there. Yeah. See the slinky little extension cord on that? Well, that's it. That's what you get when you buy Wing Wang. Anyways, it's just to show you the dangers of using heaters. And then some people, because I laugh when I see that. I seen that on YouTube, okay? And I not mention no names or nothing. He had a radiant heater on the floor. He had an extension cord, probably number 16 wire. You could most of these there. Woo, woo, woo. Can you tell I'm getting excited here? You take this and you just touch the end, the plug. Just touch the plug end. Sometimes just touch the wire next to it, and you'll feel the heat. Well, if you can feel that, that means things aren't going good. And if you have any weak spot, when I'm talking weak spot, I'm talking a place where your screw ain't really tight in a plug, and you're plugged in on the circuit that's got 8-10 different plugs like that, just in series like that. Well, you're lucky if none of them, if they're all real tight, plug that in, because like I told you, every joint is the weak link, eh? So it'll heat up. So it heats up a little bit here, a little bit there, a little bit there, a little bit there. The extension cord heats up because it's only number 16, and you're drawing for the capacity of a number 14. You got it plugged in here, and first thing you know, smoke's coming out of the plug. Or if you're real bad lucky, you're not home, but you left your heater on because you didn't want your little pipes to freeze, eh? Okay, so now we're down to the conclusion of this saga. What do I do? What do? You can do it yourself if you want, if you know enough about it. Or you go on YouTube, and there's people, but watch who you follow, eh? Because some people are kind of rinky-dink. I seen one guy one time. Here I am. I'll tell you a story. A guy's got a well, okay? I don't know. He's got a pump and a little caboose there, but he needs a heater in there, eh? And he's got a little 110 heater. So his pump's 220. So he's got a 220 circuit to the well, to the caboose. Now he wants to put a little heater in there. So what he does, he runs one side. So he's got 220. That's just two wires, eh? There's no neutral. He needs a neutral to get 110. The ground has got the same potential as a neutral. So he puts his plug between the power and the ground. Dangerous? You put your little feet there, your little running shoes there, you tromp it on the wire, and you go into that little well house, and it's got some water in there, and you start poking around with your fingers in there, and then boom! Yeah, you gotta stay there. These are 110 is not so dangerous, but in the proper circumstances, it can be dangerous. You can stick on it. But anyways, that's for a topic for another day. Maybe. So I don't like talking about electricity, because I know what I do, and what I do and what you can do is two different things. Okay, so did I conclude? Yeah. For a conclusion, I'd say you can fix it yourself. If you want to run a little heater like this, it's not ideal. Should have permanent heat brought in the house, ductwork, a furnace, proper furnace. If you want to run a little heater like this, you can run it. Get a dedicated circuit right to the panel for your little heater. If your panel's not big enough to put it dedicated, well, get your panel changed. That's it. That means you're outdated. And be careful, because these have caused a lot of fires. So I've said my piece now. I had fun doing this. I hope you guys, you were lucky to get on there at the station there. Woo woo, and the train was leaving, and I seen you running there on the platform there, trying to get on in the train there. Well, this is the end of the line for the Gator train today, folks. So we're past Christmas. This is pre-recorded. It's snowing out. Hang on, my finger is snowing out there today, but I won't show you. And we'll be seeing you in the new year. Well, I think I have one or two more, maybe two, but at least one anyways to do before the new year. So I salute you all. I can't tell you Merry Christmas because it's too late, but it's not too late right now where I am recording this, because we're pre-Christmas. So I salute you all, and we'll see you in the next one.